So I'm going to start by giving a little bit of background information on this topic, talk about what some other people have done and how I got interested and motivated to do this work. And then we're going to talk about some studies, one study that just got published last week and another one that's still in the works, looking at associations between living in greener areas and near water among urban Canadians. So this isn't really a new topic by any means, but it seems to be a bit of a hot topic right now, looking at associations and connections between natural environments and different health outcomes. And as I wrote on the slide there, there's a lot of studies looking at contact and exposure with nature defined broadly. So a lot of people conceptualize what exposure to nature and contact with nature might mean differently, and I'll go into that a bit on the next slide. But here I just want to say that generally there's a number of different studies have found associations between exposure to nature, contact with nature, and a number of different physiological and psychological outcomes. So things like self-perceived stress and well-being, reduced blood pressure and stress, which leads to improved sleep. And when you're sleeping better, then you feel better. You're able to concentrate better. Links between different kinds of measures of areas of green space and opportunities, how that relates to opportunities for physical activity and increased physical activity, and as well as social interaction and with people in your neighborhood, and then even reduced mortality rates. So as I said previously, in many cases, it would be a little bit of comparing apples to oranges there, and to sort of group all those studies together, because some people might conceptualize or operationalize in a study exposure to greenness as maybe the time spent, like the amount of time spent outdoors or the amount of time spent in parks. And this is very different from, say, measuring, well, how many parks are there in your community? Or do people who live closer to parks exercise more? I mean, those are both within this context of nature benefiting health, but they're sort of operationalized very differently. And as I'll show in a moment on the next slide, there's a number of studies that I find really fascinating where just looking at having a view of nature from one's window is associated with a number of different health benefits. For example, people whose bedroom window looks out, say, into their backyard over a garden or large quiet lot have better sleep. In this one study, had better sleep than people whose window is on a busy road. And you can imagine the noise and things like that. So here I just wanted to talk about three studies that I found, for me, were really interesting and kind of got me interested in this kind of work. And the first is a study by Rachel Kaplan from 2001. So this is a relatively older study, and what she did is she did interviews with residents in 6 different apartment complexes in Ann Arbor, Michigan. And these were all 1 to 3 story apartment complexes, and they were all the residents were generally sort of mid to low income people. So they were sort of similar socio-demographic characteristics and living in the same area. But as you can imagine, some of these apartment complexes, or some of the apartments, their views would be looking at just a brick wall of the apartment complex across the way, or just of the parking lot. And some other people had a view of a woodlot that was behind the building, or of a garden, or a grassy field, or grassy yard in any case. And so what she did is she went in and did interviews with people, asking them about a number of different indicators of mental well-being and how they feel about their community and the ability to concentrate and things like that, and then sort of characterize the views of the windows. Now, on this slide here, those aren't real views from Ann Arbor, but you can just imagine how you might feel if that top view is what you had out your bedroom window or from your kitchen, compared to if you had to wake up and all you got to look out at was that parking lot. And they found statistically significant associations between having views of nature with a number of different indicators of neighborhood well-being and neighborhood satisfaction and personal well-being. And so what fascinated me about that study was these people weren't necessarily even going out and interacting in the nature. So they're not necessarily exercising, they're not interacting, they're not getting social interaction with their neighbors, They're not even necessarily breathing in, say, clean air, but it's just having, being able to view the weather, being able to view the nature, was having an impact on them. So this is a study that some people are perhaps familiar with. It got a lot of media attention, and it was just a couple of years ago, based out of Toronto. And here the researchers, they had a database of all the trees in the city. And so they wanted to look at benefits they looked at a number of different health outcomes, but associated with the number of street trees. So they did not consider trees that were in people's backyards or in parks. They just looked at trees that are along the streets, and they were able to quantify that for having an increase in 11 trees in a given block decreased cardiometabolic conditions about equivalent to someone having a personal increase in income of $20,000 a year and moving to a neighborhood with a $20,000 higher median income, median household income, or being about 1.5 years younger. So that study, I found it really fascinating the way they could quantify it right down to just by increasing the number of trees like that in a given block. Next slide. So this is a study. This is a little, well, in some ways, sort of similar to the first slide, the first study I was talking about. This is in Wellington, New Zealand, and what these researchers did is they were trying to quantify from different parts of the city whether people had a view of, or the quantity of the greenness or green space and the quantity of blue space or open water from different locations. So they did this really cool raster grid across the city, where they took into consideration the slope and the aspect and the elevation and the distance and building footprints from every other location. And I've just taken a little, you can see at the bottom of the screen there, that's just a little screen cap from their article where they were sort of trying to demonstrate how, taking into consideration these, the angle and the buildings at different points would have more or less views of blue space. And then from that, they identified that people living in neighborhoods with increased views of blue spaces, now in their case, they didn't find any benefit with green space, but they found with blue spaces that people had lower psychological distress levels. So I just thought that was a really creative analysis, the way they were able to take into consideration so many different characteristics of the land cover to estimate exposure. Next slide. So, broadly, I've been saying green space benefits health and well-being, but so what are the sort of key mechanisms or pathways that might be at work here? In the literature, there are sort of three main pathways or mechanisms that have been hypothesized, and as you can imagine, they're sort of all interrelated. And the first of these relates to reducing harm, so sort of mitigating the adverse effects of different exposures. So here we would be considering things like reducing exposure to air pollution, reducing exposure to noise. For example, if you've got a lot of trees along the road, that can buffer the noise that's getting up to residences. Cooling effect, having a lot of vegetation in the city can have substantial local cooling and protection against urban heat islands and high heat events. So there in the middle box on the screen, we have restoring capacities. So this relates to sort of how people might say recharging their batteries after sort of going and spending time in the woods or spending time in nature and feeling mentally restored. So think about when you go to the beach and you're sitting there looking at the ocean and you just feel, you can hear the waves coming in and you see the sun and you just feel like, it just feels great. And it's sort of restoring your, sort of eliminating the stress and bringing you back to the start. And then the last mechanism at the bottom there is building capacities. So this is suggesting that areas that are more environmentally pleasing, maybe they may encourage people to exercise more, to go, if you've got a nice park, it's a spot you might want to go for a walk and have a chat with people or exercise. And so it encourages both physical activity and social interaction and neighborhood cohesion and things like that. Next slide. So now we're going to move into talking about some of the work that we've been working on here. And so yeah, I mean, our goal was to look at associations between cause-specific mortality and residential exposures to greenness and to water. So I'm stressing here residential exposure because that's what we're looking at. We're not looking at time spent in parks or time activity patterns at all, really. We're just looking at, we have estimates of residential exposure, and anyway, I'll explain. So the data set that we're using is the CanCheck cohort, and anybody who knows me knows I love to talk about the CanCheck. So this is, there's a couple different CanChecks, but we're using the 2001. So this is everyone who filled out the 2001 long-form census, which is 1 in 5 households. And I think most people are probably familiar with the long-form census in that it's got a lot of content related to income and age and sex and languages spoken at home and immigrant status and so on and so forth. And so all these people have been linked to the Canadian Mortality Database with follow-up through 2011. So over that 11-year period, we know who died and what did they die of. And they've also been linked to their annual income tax filings, which includes a postal code. So for every year, we've got their residential postal code, and so we can track them for the purposes of assigning environmental exposures. So for example, at baseline, we might know a given subject was, a married 40-year-old man living in Edmonton and had X level of education and was unemployed or whatever. And then 2 years later, they moved to another neighborhood, and then 6 years later, they moved to Toronto, so we can track them that way. And then in our past studies with CanCheck, we've included, and in our present ones, we've included a lot of contextual characteristics. So given that we know the postal code where someone lives, we can generate neighborhood or city level socioeconomic characteristics. We can assign estimates of air pollution, which we've done in these studies as well, greenness, blue space, and then a little pink circle there just sort of to suggest the opportunities are endless for different kinds of exposures that could be assigned. So just to sum up, in this case, we're using the 2001 CanChecks. We've got 11 years of follow-up, and now here we've restricted it to non-immigrants because immigrants tend to have very different health behaviors, and they tend to have better health behaviors and better health outcomes than Canadian-born subjects, and so they should be treated differently, I guess, as far as at these studies like this. And we limited it to people aged 25 to 89 due to some concerns with record linkage among older subjects. And importantly, we've restricted to people only in the 30 largest cities. So the purpose of these studies was to sort of look at how greenness might be a buffer against the negative stresses of urban living. And so the idea of living in a big city where there happens to be a bunch of green space around you is very different from living in a cabin in the woods, like in a rural area. So anyway, we've restricted to people living in the 30 cities, and we've got about 1.5 million people, well, 1.3. So here's a map just showing the 30 cities. So as you can see, we've got people from across the country. We have representation in all the provinces except for PI. Unfortunately, Charlottetown didn't make the cut. They're not big enough. And for the purposes of the studies looking at living near water, you might also notice we've got people in 4 different cities that have ocean coastline: Halifax, St. John's, Vancouver, and Victoria, and then a number of cities that are located on major lakes and major rivers. So here I'm going to pass over to Adele, and she's going to tell you about the specific exposure assessment methods that we've used.
Thanks, Dan. So today I'm going to talk about the different exposure assignments we use for our green and blue space studies. So for our green space exposure, we use the Normalized Difference Vegetation Index, which in short is called the NDVI, which is a satellite-derived indicator of green vegetation on the ground. And green vegetation absorbs most of the visible and reflects most of the near-infrared light. So NDI values have a range from -1 to 1, with negative values representing water and 0 values representing bare soil, and positive values representing dense green vegetation. So for our green space study that we conducted, we restricted our data to values greater than 0 to separate effects of greenness from the potential effects of living near water. We also excluded values less than 0 because NDVI is incomplete over water. So this is a sample of the NDVI layer that we created for our green space study. We created the NDVI layer for the country by downloading thousands of image tiles from NASA's Aqua satellite at a spatial resolution of 250 meters at 16-day averages. Then we calculated the annual maximum greenness values averaged over the summer months for each year from 2002 to 2011, and then calculated the long-term mean values over the 10-year period. So if we look at the slide, we can see 4 large cities in the Maritimes, Fredericton, Moncton, St. John, and Halifax. And as most of you probably know, the Maritimes has a lot of dense green vegetation, so the NDVI for this area is very dark green in color. So this slide is of the Ottawa area, and at first glance, we can see that the urban areas of Gatineau and Ottawa are shown in a light green color, which we would expect. And then we see as the white dots pop up, they represent residential postal codes where we assign each participant a 10-year mean NDVI value within 250 meters of the residence for our green space study. So this slide shows a close-up of downtown Ottawa, and we can see the Tunney's pasture area with the star marking the StatsCan building. So the black dots on the map represent residential postal codes, and the rectangles represent 250-meter grid cells. If we take a look at the Greenness NDVI legend up in the left corner, we can see how it ranges from green representing high NDVI to orange representing low NDVI. So if we go back and look at the map, we can see the spatial variability and how the dense parts of the city are more orange in color, and the areas like the Parkway that are less populated have a more green color. So in the second study that we conducted, we looked at residential exposure to blue space and mortality. And Dan's going to talk more about the results of the study later. But if we look at the map, we can see the bodies of water within and around the country. The bodies of water that we looked at for our blue space study included lakes, large reservoirs, rivers, and coastal waters. So now I'm going to go on. I'm going to talk about how we assign blue space exposures. So this slide shows the Rideau Canal in Ottawa. And in our blue space study, we want to identify subjects who live close to blue space and who may even have a view of blue space from their home or during their daily activities. Therefore, we identify potential exposures to blue space within 250 meters of a subject's residential postal code. So looking at the map, we can see that some of the points are very close to water, and these individuals would definitely have a view. However, there are some points that fall within the 250-meter buffer that are further back that may have access to water on a regular basis, but not necessarily a water view. So we use survival modeling, and more specifically a cost proportional hazard model for both of our studies. So hazard ratios look at the risk of occurrence of an event happening at a given time point and takes into account the number and timing of events. So for example, a hazard ratio of 2 would indicate that you have twice the risk of dying per increment in exposure. Hazard ratios of 1 means there's no association, and hazard ratios less than 1, for example, 0.5, would mean that you have half the risk of dying per increment in exposure, which indicates a protective effect. So in our survival model, we controlled for confounding by including personal, community, and environmental covariates. So some of the personal covariates included age, sex, visible minority status, Aboriginal status, marital status, education, income, and labor force status. And our community indicators included the CMA indicator for the 30 major cities in the country, unemployed adults, percent of adults who did not complete high school, percent of low-income families, and population density. So population density was used to capture living in a denser urban core as opposed to living in a more suburban area of the city. So, and then finally, we included environmental covariates, which included measures of air pollution. So now Dan's going to pick it back up from here, and he's going to go through some of the results from our green space and blue space studies. Thanks.
Okay, thanks, Adele. And next slide, please. So here I'm just showing some descriptive statistics from the greenness exposure. So on the left there, you can see on average for all subjects, the mean value of the greenness was 0.58. So recalling that NDVI slide that Adele showed, the values range NDVI has a theoretical range of 0 to 1. And in our cohort, some subjects actually had as low as a 0.13 and as high as a 0.96. And so in that little table on the right, I'm just showing that among those people who were in the lowest income quintile, which is a lowest income bracket, had on average their greenness exposure was a little bit below than the overall average, and those who were in the highest income quintile were above that. So there's a little bit of a gradient there in terms of income-related exposure, and then the same sort of gradient is shown there among those who did not complete high school compared to those with a university degree or more. Now, the standard deviation is quite large there, so these differences may or not really be that meaningful. So here we're showing some hazard ratios, and the bottom line in the table is just another way of interpreting the associated reductions in mortality risk. So we looked at a number of causes of death, but here, just to keep the slides from being overwhelming, I'm just showing for 3 common causes. And so in the case of non-accidental, we see a hazard ratio of 0.915, which is about equivalent to an 8.5 reduced risk of mortality associated with a change of 0.15 in the greenness index. So to put that, just the way that can be interpreted is that holding constant all the personal characteristics, so the age and the sex and income and employment status and so on, as well as all those different neighborhood characteristics, and controlling for the level of pollution and living and what city you live in, we're still finding above and beyond all that an 8.5% reduced risk of non-accidental deaths associated with living in a greener area compared to living in a less green area. And if you think back to that map of Ottawa we showed a minute ago, there was that much variability. So those orange areas, which are just a few blocks away at the right-hand side of that map, had NDVI values around 0.4, and then at the left side of the map, which is just a few blocks away, they were in the range of 0.6. So that's sort of the change in exposure that we're talking about to achieve these benefits. So there's a lot of numbers on this slide. You don't really need to look at them all, but here the top line is the hazard ratio from the last slide there for all non-accidental mortality in the whole cohort. And then here I'm just showing that when we break it down into different subgroups of the population, we found much more protective effects among men. So men were benefiting more from the same amount of exposure. And we see a real social gradient in health here with more protective effects among those in each higher level of highest level of education accomplished or completed, and by highest levels of improved benefit at each step of income quintile. And in fact, in the one line that I've underlined, that's suggesting that among people who were in the lowest income quintile, they were really getting no benefit. They didn't benefit at all from having the greenness exposure. And so again, just to put this in comparison, as we're talking about, if everything else being equal and you're in the lowest income versus being the highest income, the same amount of greenness gives a benefit to the one group but not to the other. So here we plotted a concentration response curve. So across the bottom of the graph there, going from is the range of greenness, which, as I've said, goes from 0 to 1, and then up the y-axis is the associated hazard ratios. And so all I'm showing here is that it sort of plateaus. For example, if your level of exposure to greenness is about 0.2, there's a big difference in the hazard ratio between someone who's at 0.2 to 0.4, whereas once you get up around 0.65, whether the greenness around your home is 0.65 or 0.8 or 0.85, the benefit is about the same. So just to kind of highlight the key findings from this study is that we found really strong protective effects for several causes of death associated with residential exposures, and this was, as I've explained, after controlling for many personal environmental risk factors. And then, as I've also suggested, that some of the more affluent populations are having not only possibly greater exposures to greenness, but also increased benefits associated with those exposures. So now we'll move on to blue space. And I bet everybody really, just looking at that picture, you're already feeling like, yeah, I feel more relaxed already. So here, I just wanted to provide a little bit of descriptive statistics on the people who were quote unquote exposed. So that is those who were living within 250 meters of water at baseline, compared to those who were not. And these, for me, I was very surprised how similar these characteristics were. Now, we had a lot more characteristics. I only showed a bunch here on this slide. But you can see the proportion of people who didn't complete high school. I mean, it's within 1%, between those who live next to water and those who don't. 2% more had a university degree. The percentage in the lowest income decile, so putting everybody's income into 10 categories, and those who are in the lowest group, identical. There were slightly more higher income people in the exposed group. And one thing that the biggest difference between the groups are those last two there, the employed and not in the labor force. And the only way this might have an impact on our findings is that people who are unemployed may be around the house more, so may have more exposures to, have more time to have residential exposures. And similarly, people who aren't in the labor force. So that would be people who are retired or people who are on leave from work. There were, 5% more among those in the exposed group who were not in the labor force. But really, they're pretty similar overall. So this is similar to the slide I showed earlier. And again, we looked at a bunch of different causes of death. I'm just showing a few here. And here we found even more protective associations than what we found with the green space. So again, the way this can be interpreted in the case of, say, the first column there, non-accidental mortality, that controlling for all these other personal and neighborhood characteristics and the level of air pollution and so on, we're still finding that just living within 250 meters of water compared to those who don't was associated with a 12% reduced risk of mortality. I do want to state these aren't published yet. These are preliminary findings that I expect they will get published, but these are still preliminary at this stage. So just to sort of wrap up those key findings, I'd say we were all very shocked at how strong the associations we were finding with blue space. It seems like that may be much more important than previously expected. There are no other studies that have looked at risk of mortality and exposure to blue space published anywhere, so we can't really compare these to anything else. But similarly to the green space findings is that these findings here suggest that really everyday residential exposures can have important benefits to health. And so this might be different from, say, going and spending a day at the beach or spending time out on a canoe or on a boat. This is just having, possibly being able to lie in bed and hear the water, or being able to sit out on your back deck, or, during your daily, within 250 meters, it's probably part of your daily activity space, walking around and so on, you getting a view. And so overall, among these, I'm kind of talking about both studies here together now. The main strengths, a really large sample size here. We've got 1.3 million people, so it's great. Again, I can toot the CanCheck horn all day. It's national in scope. It's great. It's longitudinal. We had it's 1.3 million people followed for 11 years, so it's very representative. There's not a lot of chance for random error in there. The exposure data that we have, an advantage of them is that they're available in consistent quality across time and across the whole country. So we could get equivalent kinds of exposures for people in all these different cities. Thinking back to that study I described in New Zealand, they used that really awesome, sophisticated model, but you couldn't roll that out nationally, or you could, but it would be a lot of work to do something that kind of a model on such a large data set. So this is limited, but it allows us to include more people. And then again, we were able to control for so many personal environmental factors, including estimates of exposure to ambient pollution. So some of the limitations, while 250 meters is sort of relatively, it's just an arbitrary distance. We could have picked 200 meters or 500 meters, and we may have got different findings, but it's what we went with. And then really the key limitation of the greenness data in particular is that it's really only describing the amount of vegetation and the amount of greenness, and not really the quality of it or the accessibility of some of these spaces. So, for example, and I think this is contributing to why we're seeing different effects by socioeconomic status, is that maybe someone who's in a more affluent neighborhood, they've got a lot of greenness around them, and it's a really nice garden, it's a nice manicured lawn, there's really nice shrubbery. And someone else who's got a lot of greenness around them in a less nice neighborhood, it might be just grass. So they're both green, but the qualities can be very different. Or it could be a woodlot, or it could be a cornfield. We can't really differentiate between that here. And then again, the water, it's not necessarily accessible or visible from the home. We can't state that, and we don't know how, if people are actually going and spending time there. It's just you live near it. So some remaining questions for me or anyone else who wants to take up the challenge. There's still a lot of work that could be done on dose-response relationships. So what's more important, the frequency of visits or the duration of visits or exposures? I've seen some studies, one study in particular, where they found the frequency of trips to, quote-unquote natural spaces or green spaces was associated with increased physical activity, whereas the duration was more associated with reduced stress. So that different kinds of exposures are going to lead to different kinds of benefits to health. As I suggested on the last slide, the relevant spatial scales. So, what's more important, the amount of green space in the area immediately around your home, or maybe in your home neighborhood, or maybe in your city. You don't spend all of your time at home. And then really the effect modification by age, sex, and socioeconomic position is something that really needs a lot more investigation. So I'd say for me, the key implication of both of these kinds of studies, or both of these studies, is that we're really showing that general greening and residential exposures, but general greening of a community can have benefits beyond those associated with improving or increasing parks. There's a movement I know this is happening in Vancouver and in other cities around the world, where they're deculverting, I think is another name for it, where they're rejuvenating old streams that have been sort of built up over in urban areas and sort of reintroducing the stream into an urban area. So that's a way of giving people access to some blue space in the city. So I guess what I'm trying to say is that it's, when a city is, say, trying to decide, how should we invest in greening initiatives, that, adding to parks, adding new parks or improving the quality of parks is one thing, but I think what we're showing here is just having a lot of trees out and about and everywhere in where people are living is important. So here's my long list of collaborators and supporters. As I said, some of these people provided some of the exposure data, some of them contributed to the analyses, and everybody contributed to, interpreting the findings and writing up the manuscripts. And so I just wanted to acknowledge, and both Canoe and MSSU have helped us publish the paper and helped promote it. And I think that's in one more slide, and that's it. So yeah, I just want to mention the Greenness paper was just published last week in Lancet Planetary Health, and the blue space work we're writing it up right now. And so thank you very much for your interest, and thanks again to Canoe for hosting us. And we're available for questions for next little bit.
Great. Wonderful. That was a super interesting presentation. Thanks, Dan and Adele. Certainly, I've got a few questions written down, but for those of you on the line, I'd like to ask you to type your questions in by the chat box. You'll see them popping up on your right-hand side, and Dan and Adele, maybe you can address them as they appear. So, Dan, we've got one there. Can you see it?
Yeah. Oh, I was going to type it. I guess I can speak it, right?
You can speak to
it. Yes.
Perfect.
Yes, so we used a 250-meter distance in both cases. Now, I didn't go into this in the presentation just because I was trying to keep it short, but we did also look at 500 meters. And in the case of the green space, we actually found, or greenness, we actually found more protective effects at 500 meters. And so I think in the case of the greenness, the 500 meters maybe was a better representation of people's activity spaces and areas with which they might have regular exposures. And in the blue space study, once the water at 500 meters and beyond, the associations were much more attenuated. So I mean, at that distance, you're not there wasn't nearly the benefit. And I see there's another question about, is it possible to see results for different cities? We haven't presented those in either of the papers, and part of the reason for that is that the individual sample sizes in each city are quite low, so you end up with really kind of wonky confidence intervals. And I mean, some of the bigger cities, it's one thing, but a lot of the cities we end up with like only about 1,000 deaths, and so they're just really not very stable. So we haven't really looked at them on their own. You really need you don't need 1.3 million, but you need more than a few thousand to do this. Why would vegetation? I reading Audrey's question, which is how about negative impacts of vegetation such as allergenicity or risk of violence and crimes? I'm not sure how violence and crimes comes in. I have seen there, and you're right. There's definitely a mixed findings on allergies. Some people, I've seen some studies where they find allergies are allergic symptoms of allergies are lower because of in some ways, but in other cases it aggravates them. So it's a little bit mixed. I think I would really like to see some studies that can try to differentiate between the kinds of trees and the kinds of vegetation and how those might have different benefits. And I've also seen, and I don't know, I haven't seen anything, I've seen just some sketchy data on this, that increasing trees can increase car accidents because it's something like on road, increasing trees along the roads because it's something hard for cars to crash into. I don't know if there's any, how that would, what the trade-off would be there. Burglars hiding out in trees. Wow. Yeah, I don't know. I don't know. So yeah. Okay. Do you think that finding no benefits for lowest income group may be due to other factors that are more important for their health? Yeah. There's a famous study in the Lancet in 2008, Mitchell and Popham, where they found the opposite, that people who were in the lowest income, I don't remember if it was quintiles or how they did it, but the people in the lowest income group were benefiting more than those in the highest income associated with greenness, and it was at more of a community scale. And so they were sort of hypothesizing that these people, the poor people or less affluent people, were they standed to gain more. So their health, they were starting at a lower baseline health, and so having the green space was able to be more meaningful for them, whereas the more affluent people already had pretty good health, and that the greenness didn't really add to them. But as I say, we found the opposite here. So Eleanor asked, if I were a city planner, what would I take away from this webinar? Yeah, as I was trying to get at there on my last slide is that I think what we're showing here is that general greening around, out and about in where people are living, is important. So it isn't just a good idea or just important to have parks or to invest in parks, but to invest in, say, trees along the medians or in other public spaces, and not just trees, but vegetation that just around where people are living seems to be important.
Again, really fascinating study. Actually, one thing we talked about previously about the type of blue space, and I was thinking, well, if you live near the beach, that's great, but I think you mentioned that it wasn't really, the size of the exposure to blue was not as important as just having any kind of water nearby. Is that right?
Yeah, we did some preliminary analyses that we've ended up not using because of various reasons, but we were trying to differentiate between the kinds of water, and we just don't have the right data to do that.
Okay.
Other than saying, picking the people that live in the cities by the ocean, it's the data set that we have is really just sort of water or not water. But it's funny you say that. I have a buddy who lives in Victoria, and he was saying, yeah, I moved here, and he was in Vancouver at first. This is where this was happening. And he said, yeah, I love the idea of the beach, and I'd be at home like, let's go to the beach. It's going to be great. We can get there. And he said, then I get in my car, and I got to drive. It's 40 minutes of traffic, and I'm so stressed out. And then I get there, and there's like a million people. I can't find a spot to sit. And I'm like, it's terrible, So it's like, it depends on how you're using, just being near the beach isn't necessarily good. It depends on how you're using it and your kind of experience you have.
Great.
Someone asked if we're looking at mental health outcomes. That's really where we want to go next. You may have noticed we looked at dementia in the blue space one and found protective effects. And I'd really love to get my hands on the CLSA data, Canadian Longitudinal Study of Aging. And I'm hoping to get access to the CLSA, which is, I'll just say really quickly, it's a data set of about 50,000 Canadians aged, I believe, 45 at baseline, 45 and older. So it's older adults, and there's all kinds of information on mental health and physical activity and where they live. And anyway, I would love to look at that and Greenness. Or maybe CCHS. CCHS, Canadian Community Health Survey, also has a lot of information on mental health. We're thinking about that.
Mm-hmm.
That one might be interesting because I think they have full residential history connected to the CCHS now, and I know CLSA does not yet.
Right. Someone asked, is there similar studies done in low-income countries where greenery is very scarce? Most of the studies on blue space. There's a lot in both blue space and green space. Most of the research is Europe and Australia. There's not that much in North America, not as much in North America. But I can't think of in any developing countries or Asian studies that are jumping out at me that in my memory. My dad and I were talking about this over the weekend, and so we were talking about maybe having views of just scenic vistas. As I've said, part of the benefits to health have to do with that are really vegetation related. So cleaning of the air, acting as a buffer, cooling, providing a desirable place for physical exercise, and so on. But part of it is just having a nice view, I think. It can be quiet and restorative.
All right. Well, we're getting close to the end of our time, and unless anyone's got any hot topics they want to introduce either verbally or by chat, I think we'll just wrap it up now. And just on behalf of everyone, I really want to thank Dan and Adele for putting together such a great presentation, and it was nice to see those interesting results and easy to follow, and we really appreciate the work you're doing. So with that, I'll say thanks, and we'll end our webinar.
All right, thanks.
Thank you.